ओके 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 राइट, चलो चलो बाय बाय बस। तो यशमित बहुत ग्रेट है भाई, बस वापस आ जाते हैं। ओके, क्या समझा रहा था मैं, और व्हाट वर वी वर स्टार्टिंग फोर्सेस, सिंपल फोर्सेस से स्टार्ट करते हैं। Force is a push or pull. It can change direction, it can change speed, it can change shape, है ना? It can also produce a turning effect. मैंने ऐसा समझाया था क्लास में, और फिर मैंने मोमेंट्स थोड़ा सा मोमेंटम भी कराया था। अच्छा, तो स्कूल की बात कर रहा था कि नहीं कराया? क्या? कपल्स तो ये मोमेंट्स એટલે જ कपल्स થાય नहीं, मोमेंट मोमेंट करे। Okay, what are the laws of motion? Let's start with laws of motion. What are the three laws of motion? The first law states that, but what does it state? है ना? तो if a is equal to 0, f is equal to 0. If there is no change in velocity, then there is no force acting. But for velocity to change, there must be force, है ना? So should I be writing it like this, that if f is equal to 0, a is equal to 0, है ना? What is the second law of motion? The second law of motion directly ऐसा बोल देता है कि f is equal to ma, है ना? है ना? But let's take a little bit detour and let's understand how does all of this come into existence, right? When we are looking at forces, when we are looking at motion of objects, right? Let's say there is a object which is moving at a velocity of 5 meters per second, and the mass of the object is 1 kilogram, right? If we want to measure the motion of the object, we give it a name which is known as momentum. Momentum, denoted by letter P, which is also a vector quantity, is written as m into v, right? So what is momentum over here? 1 into 5, which is equal to 5 kg meters per second. ठीक है, ये मोमेंटम हो गया. बट नाउ इफ यू अंडरस्टैंड दिस, मे आई राइट दिस एज v meters per second and m kg, right? If I wanted to change motion of this body, now if you apply the first law of motion to this, what will you find? You will find that you have to take this velocity to some other velocity, let's say u meters per second, है ना? What have you essentially done? You've changed the momentum of the body, right? We know that v minus u, this change can be achieved only and only if there is acceleration or deceleration, because this will be happening in a particular time period, right? So this can only take place if there is acceleration or deceleration. So a body stays in its motion until unless an external force is applied. Now how do you define that force? So let's say that this momentum change, right? P2 is equal to m into u, P1 is equal to m into v, right? Delta P is equal to mu minus mv, or I can also write it as mv minus mu, right? Both of them are same. Only when they're asking has the momentum increased or decreased, it matters what you are taking first, है ना? Otherwise final minus initial is the best, but because मैंने ऐसे v और u थोड़ा उल्टा लिया है तो मैं ऐसे लिख रहा हूँ, है ना? Now this change in momentum is also known as impulse, right? What is impulse? Impulse is change in momentum of the object. Now as the impulse changes, है ना, क्या हो रहा है impulse में? वो change हो रहा है. कैसे change हो रहा है? When you are applying a force, right? Now to understand what else is needed to complete this equation, let's think about it like this, that if you wanted to change impulse quickly, you'll also have to apply more force, right? So if force applied is more, the time taken is less, so they are inversely proportional, right? So somehow force is proportional to the change in momentum and it is inversely proportional to the time that requires to produce this change. The greater the force, the greater the change in momentum. The greater the force, the lesser time it takes to change this momentum. ऐसा बोल सकते हैं हम. Now let's say the equation becomes like this, where k is the constant of proportionality, but experimentally पता चला कि value of k is 1. So we can directly write that F is equal to delta P by delta T, where P is the change in momentum. And therefore force can be defined as rate of change of momentum. But if you take this equation, you can write F is equal to mv minus mu upon T, which can be written as m into v minus u upon T, which can be written as ma. So now you can for sure talk about the first law of motion, that if force is 0, acceleration has to be 0. If there is acceleration, there is for sure some force, right? This is the second law of motion. The statement, this equation is the second law of motion, right? And the third law will make sense when you think about masses, right? If let's talk about this board. Is it moving? Does it have mass? Yes. So if it has mass but it does not have acceleration, will it have any force on it? Makes sense. There is no force on it. It is true. But does this board have some weight? Will it have weight? Because gravity is continuously pulling it. What is weight? Weight is a kind of force. Weight is W is equal to m into g. So it would be true saying that there is no resultant force on this TV, है ना? ये जो स्क्रीन है, ये जो बोर्ड है, इस पे resultant force नहीं है. For sure there is weight, but the resultant of this is somehow 0. How can it be 0? So let's say पीछे क्या होगा यहाँ पे टीवी पे? हाँ, but let's say there is a hook through which it is hanging on this wall, right? The screen is hanging, let's say it has a weight of W Newton. These two supports provide upward force of W Newton as a total, right? So every action has an equal and opposite force when the body is in equilibrium. Even when it is not in equilibrium, this always exists. Even when I'm walking, right, I'm applying force on the ground and then I walk forward. The ground also forces back, है ना? So action and reaction pair should be same. If I am applying active force on the ground, ground is applying reactive force on me, right? A big confusing classic example बोल सकते हैं. If you are sitting on chair, right, your weight is the active force on the chair. What is the reactive force? The chair on you. No. Earth. Because the active force is weight, the reactive force has to be weight. Okay, so remember this. Try to deduce what is your active force and then only talk about the reactive force. This makes sense? पक्का active reactive forces equal है. अभी यशमित, let's look at this. If this is at a distance of 1 meter and this is at a distance of 2 meter, will both of these supports have the same opposing force? No. But to understand all of this, first we have to remind ourselves that when the cumulative force is 0, the body is not moving in any direction, right? But let's say that no matter how tightly I hold it like this pen, right? If there is a force in this direction, the pen will rotate about its axis. है ना? Why is that? Because the moments are not 0. Momentum and moments are different things, है ना? तो moments are not 0. If moments and forces, if the total of moments is 0, and if the total of forces is 0, only and only then you can say that the body is in equilibrium. It is not moving in any way. Makes sense? It is not going to change its motion in any way, right? Let's say this is not W Newton, let's say this is 90 Newton, this is 1 meter, this is 2 meter, and we are supposed to find how much is the reactive force from each of the supports P and Q, right? If I take this as my pivot, okay, this is where everything is going to rotate about, then at this distance this pivot is P multiplied by 3, right? And this is giving an anti-clockwise force, anti-clockwise moment due to the weight. So this should be equal to 90 into 1, right? So in this case P should be equal to 90 by 3, which is equal to 30 Newton. Make sense? Now the total of P and Q should have been 90. So Q will be 60 Newton. And you can prove it. Let's say if this was your pivot, right? Then Q multiplied by 3 should have been 90 multiplied by 2. है ना? So if that is the case, then Q is equal to 90 into 2 by 3. 30 into 2 is 60 Newton. In both the cases, we are finding that the reactive force on or at Q is equal to 60 Newton. If this is true, only then this board is in equilibrium. Otherwise, it's either rotate or move somewhere. Makes sense, right? Now you have a lot of examples like this, that okay, this is the wall, this is floor, and this is your ladder. Okay, there is a reactive force like this due to contact. This is also known as contact force. There is a force like this, है ना, which you should consider when answering questions, है ना. And let's say they are saying that there is a flag that has a hinge over here. Table office ma, this will have a reactive force in this direction because it is pushing down, right? This is pushing it down, and inside the reactive force will be outwards and upwards, right? You have a lot of MCQs where you have to just show the direction of the resultant force. So in that case you remember all of this. ठीक है, ये समझ में आया? फिर और क्या है? एक लास्ट है, that momentum is always conserved by couple. क्या होता है? Let's say एक bench, ठीक है? Now there is a force F applied over here and force F is applied like this. Rather थोड़ा better लिखना हो तो ऐसे लिख सकते हैं कि force F is applied like this, right? Now the total forces are 0, but if there is a pivot here, right, this will rotate like this. What will be the torque on it? The torque will be, let's say this is distance d, it will be F into d multiplied by 2. That's it. ठीक है, this is the this is that. Okay, torque is the turning effect produced by the force. Okay, the turning effect produced is this. Make sense? Now sometimes it may also happen that there is a object, right, and it is fixed over here in such a way that this does not go all the way down like this, है ना? Let's say it's a flap, है ना, which does not go down like this, but instead the hinges over here, or if I'm saying this is a flap, let's say this is a flap and there is a hinge over here and this can move like this. If the hinges provide some torque, then this flap cannot become flat. It will stop somewhere here. So then you can say that that is a resultant momentum, right? And again equate the momentum caused by the mass of this flap. You know, that is also, they can say that that is also torque. Turning effect has been produced due to hinges. Hinges are opposing some turning effect, right? All of that is torque. Make sense? ठीक है? और क्या है मोशन में? चलो अब मेरे को थोड़ा याद करो. What else is there? I know there is momentum, there is resolution of momentum, right? Terminal velocity. What is terminal velocity? मेरे को एक टेक्स्ट बुक दे दो, हम लोग पूरा. Then we have correct, that is terminal velocity, right? Okay, so kinematics describing motion is done. Then we have accelerated motion, reducing acceleration, measuring velocity and acceleration, right? Equations of motion we have done, right? Then we have acceleration caused by gravity, and we have also understood projectile motion, right? Then we have just a second, forces, mass and acceleration, identifying forces, okay, friction, upthrust, tension, all of these forces. Then we have Newton's first law of motion, balanced and unbalanced forces, free fall. We'll come through fluid, we'll look at upthrust and all of that, right? Newton's third law of motion, SI units, 7 base units. Where is it? Terminal velocity. Oh, એવું છે? अच्छा, so top speed and अच्छा, so what is શું હતું? Yeah, where the weight is. Okay, so what happens is when something is falling, right, it has a weight which pulls it downwards, but as soon as it starts falling downwards, it has an acceleration which has a value of 9.81. So its velocity goes on increasing. As its velocity increases, its air resistance also increases. This will reach such a point that the air resistance is equal to the weight. Once that happens, force is zero. As soon as force is zero, acceleration becomes zero, and that is the maximum free fall velocity that that object will have, which is known as terminal velocity. Yeah? And this terminal velocity happens only in fluids, right? Solid में क्या होगा? जा ही नहीं पाएंगे ना. हाँ, okay. So that is terminal velocity. So air resistance, right? Then drag, all of these are different ways to say that there is resistance, right? Which is due to different frictional forces. है ना? Then what do we have? Explaining motion. Guys, तुम लोगों को डाउट है, तुम लोग थोड़ा तो पूछो कि सर ये कैसे होता है, ये बताओ. चलो एक इंक्लाइन प्लैंक ले लेते हैं. हाँ, अपथ्रस्ट पहुंचना बाकी है, अभी मोमेंटम का रिजोल्यूशन सिखाऊंगा, फिर अपथ्रस्ट जाएंगे. तो let's take inclined plane. Let's say this is theta, okay, and this is the box body जिसका weight होगा W, है ना? Now only a part of this weight is going to make it go downwards, which is this force, है ना? अगर हम इसको ऐसे resolute करें, right, and if this makes a triangle, then this angle is actually 90 minus theta. Yes. If this is 90, that is theta, this has to be 90 minus theta, right? and we know that nearer component is cos theta. So we must have cos 90 minus theta, which is sin theta. So the horizontal component or the component parallel to the inclined plane is sin theta and w sin theta, and this is w cos theta, right? So what have we understood right now? We have understood that the angle or the component that is horizontal is cos theta and the vertical is sin theta. But in this, what is happening? The horizontal or the one that is parallel to the inclined plane becomes sin theta and this is cos theta. So they interchange. Just remember this and try to apply this whenever there is an inclined plane, right? The angle or rather the trigonometric identities for those angle changes. So let's say I am pulling this box upwards with a force F, right? If I am pulling it upwards, force F has to be greater than W sine theta if it has acceleration. If it is at constant velocity, it is equal to W sine theta, right? If they have given a tension T in this thread or in this rope, right, then the force F is equal to T plus W sine theta, right? Tensile forces in the rope plus the force to overcome this downward force. Hmm. क्या बोल रहे एग्जाम्पल जो see this is cos, this is sine, right? The nearer to theta is cos theta. Here also the nearer to theta is actually cos theta, but what is the value of theta itself? You will see, we are talking about this angle. આ angle છે ને theta છે જ નહીં, angle 90 minus theta છે. What is cos 90 minus theta? Sin theta, which is why, huh? Yeah, the other side also. Obviously I can write it like this, that this is theta, so this has to be cos theta and this easily becomes sin theta. Yes, ऐसा बोल रहे हो ना? Correct, correct, सही बात है. ऐसे भी आपको समझ पड़ी? Confirm? Okay, so that's that. Then we have a example that has been asked a lot of times. Then let's say there is a ball like this and like this, and these two are traveling in this direction, right? After collision, what happens is these two balls join together and start going in a common direction like this, right? They will ask you to find a lot of things, but before you find all those things, there are a few assumptions or few laws or few derivations that you need to remember. The first one is momentum before collision is equal to momentum after collision. This comes from third law of motion. We don't need to go into that. Just simply remember that the momentum before collision is equal to momentum after collision. So what will you do? Let's say this is 3 meters per second, right? And it has a mass of 2 kg. This also has a mass of 2 kg and has a let's say 5 meters per second of velocity, right? Now you must have, let's say this is 3 meters per second of velocity, right? This is it does not matter which is which, but let's say this is 2 kg. Okay, this is also 2 kg. Makes sense? This is the question. They are asking that these two balls collide like this and then they start going in a common direction like this. What is the angle with which they collide? That is the first thing they can ask. You can use resolution of forces to answer whatever they are asking. But even before you do that, they can ask, is this collision elastic or inelastic. What is an elastic collision? Where there is no loss of energy, right? What is an elastic collision? No loss of energy is elastic collision. One where there is loss of energy is inelastic collision. Let's quickly find out. मेरे को कैलकुलेटर लेके सब लोग हेल्प करने लगो. हाफ 2 into 5 square, half 2 into 3 square, right? This will be half 4 into 3 square. Clearly there is energy lost, है ना? But there is one more way. Instead of finding energy, there is one more way where you can say if the collision is elastic or inelastic. What is that way? The velocity of approach is equal to velocity of departure. Now they are approaching each other with a certain velocity at an angle. It's a little difficult to find out that velocity, but we will. But can you see that they are coming towards each other? Even if this was vertical, they are coming towards each other with a velocity of 5 plus 3, 8 meters per second. So whenever they are in same direction, let's also write this down, है ना, over here, that if same direction, add
same direction, subtract opposite direction.
subtract if okay मैं समझा देता हूँ भाई. यशमित good one, thanks. यशमित मेरे भी सर है. Okay, so they are going in opposite direction. Here the two balls are going in opposite direction, so you will add the velocities, right? This is opposite direction. If this was happening, is also opposite direction. This is same direction, and on the other side also it is the same direction. So the relative velocity is difference between the two. Here it is the sum of two, है ना? Makes sense? Now here what is the velocity of departure? है? What is the velocity? The velocity of departure is 0. They are sticking together. They are not departing. Right? The velocity of departure is 0. So even without calculating all of that energy, I can for sure say that it is an inelastic collision.
So the paper can use this also. You don't need to find energy. You can just write
But sometimes they will ask energy.
Use energy to
But if it is a 1 mark question, then for sure you have to use velocity of approach is equal to velocity of departure. Whenever it sticks together, has to be an elastic collision, right? Now, let's find the angle theta, because this momentum is also vector. I can resolve momentum in two components. What are these two components? Let us, this and this, right? Because this is, let's say this angle is 2 theta, है ना, थोड़ा easy रहेगा हमारे लिए. तो let's say this angle is 2 theta. तो ये क्या हो जाएगा angle? See, if this part is theta, this part is theta, this is also theta.
Yes.
है ना? So this is 2 into 5 into क्या हो जाएगा ये? Cos theta. Right? This is also theta. तो ये हो जाएगा 2 into 3 into cos theta, है ना? ये हो जाएगा एक सेकेंड, ये क्या हो जाएगा 2 into 5 sin theta, एंड ये अपवर्ड्स हो जाएगा 2 into 3 into sin theta, है ना? Now what you should be able to write that 2 into 5 cos theta plus 2 into 3 cos theta is equal to 4 into 3. Make sense? From here only theta is unknown. You find that theta, you multiply it by 2, तुम्हारा आंसर आ गया. क्यों? Why?
If not satisfy others, half of the equation over.
क्योंकि मैं क्वेश्चन मैंने बनाया है भाई, लॉजिकली करना चाहिए, वो क्वेश्चन मैंने बनाया इसलिए. See, simply what you can also write that 2 into 5 into sin theta should be equal to 2 into 3 into sin theta. कभी भी नहीं होगा ना, कोई भी थीटा की वैल्यू के लिए एक्चुअली नहीं, क्योंकि मैंने क्वेश्चन बनाया है. राइट नाउ व्हाट यू शुड बी एबल टू आल्सो कंक्लूड फ्रॉम हियर, ऐसा भी पूछ सकते हैं कि हॉरिजॉन्टली गाइस का मीनिंग क्या है. इसका मीनिंग है कि दोनों का वर्टिकल मोमेंटम एक दूसरे को कैंसल आउट कर रहा है. The vertical momentum is cancelling out each other, which is why it starts going in horizontal direction. Otherwise, it would have some vertical component. Only if the vertical components are exactly cancelling out each other, you find that there are no vertical components. Make sense? और कुछ है ना. अब मैंने एक्चुअली ऐसा बोला था, हम लोग स्प्रिंग्स, आर्किमिडीज प्रिंसिपल, ये सब नेक्स्ट करेंगे. तो व्हेन क्या करेंगे नेक्स्ट क्लास में, आई मीन वर्क डन, एनर्जी, कंजर्वेशन ऑफ एनर्जी, राइट, पावर एंड springs and combination of springs and fluids, Archimedes principle. Right, with that आज खत्म करें अब. बाय बाय.